solve. All right, so quadratic. If I was to take my calculator and to graph this, let me clear my scratch pad so we can do it all together. You can have a calculator follow along, but it's up to you. You don't need it. Okay, so quadratic. I go to the calculator and I put in x squared, correct? And this is called the what of my function. If it's just the function by itself, it's my parent function. So my parent function looks like this. What is the shape called? Parabola. The shape is called a parabola. There we go. So I'm going to attempt to draw my best parabola. Now please do not judge my artistic abilities. I've been trying all day to make this look a little better than what it's come out. Okay? So this is a parabola. And I'm going to let my parent function, I'm going to call it the PF, be in blue for our notes. Okay? So that's my parabola. Well, it wants to know, the first thing we're starting off with, what happens to my parabola if I make it a negative x squared?
Reflect.
It's going to do what?
Reflect over the x.
There you go. Nick says it's going to reflect over the x-axis. So just to verify what he said, we're going to hit tab again, and we're going to type in negative x squared. And what does it do? Reflects over the x-axis. Okay, so that was in red. So I'm going to do my transformation in red. What is this thing doing? Red. All right, so again, me and my drawing of a parabola. You know what? I got a better idea. Let me just copy. Doc B.
Doc B?
Mm-hmm. Is that cheater? Hey, I'm using my resources. All right, there's my reflection. All right, so on this line we can describe the transformation. So our transformation is a reflection over the what axis? Do we all remember this?
No. Yeah.
Who said no? Were you saying no to be funny?
She said.
Oh, well, yeah, you were. All right. Now we're going to go on to the number that could also be on the outside with the negative. So if I'm moving on, so if I have a number, let's take 2. 2 right here. I have y equals 2x squared. Okay? What do you think is going to happen to my parent function? It's going to do what?
Stretch.
All right, Nick said it is going to stretch. So I'm going to hit tab, and I'm going to take that negative away, and I'm going to put a 2. What happened to my function?
It gets stretched.
It stretches. It stretches what direction?
To the
outside. Up and down.
What is this?
Horizontal.
Up and down is vertically. So it's going to stretch vertically. It's a vertical stretch. So what we need to know is what did the graph do? Well, it stretched.
Well, can we say compressed horizontal?
No, just leave it like that.
Compress means to.
Yeah,
But it would be the same thing, right?
essentially. When we're talking about compressing horizontally we're trying to refer to when we have the value on the inside with x.
Oh, so this is with y. This is y.
This is affecting the y. Okay, does that make sense? All right. So what did the 2 do to the graph? It stretched. So here I'm going to put
Stretch vertical.
when, I want to make sure I write it, when equal to, well, I'm sorry, when greater than 1. Then 1 is going to stretch vertically. Okay, let me paste my little parabola looks dead. Beautiful, beautiful little parabola. I'm going to copy it, paste it again, but this time I'm going to make it a little skinty. I know I'm cheating. I know. Guess what? It's okay. Boom. There's my little stretch.
Wow, stretcher.
Okay? Alright, so if it's stretched vertically, what's going to happen when I make it a half?
It's going to compress vertically.
There we go. Because instead of me pulling it like this, I'm now doing this. I'm smushing it.
Whoa.
Okay? Instead of pulling the dough, instead of stretching my dough out, I'm now taking my dough and I'm compressing it. That's why it's called compressing vertically. Huh? Horizontally looks like this. Stretching horizontally means I'm getting wider. Whereas compressing horizontally means I'm getting thinner.
So if it was stretching horizontally, what would that
Stretching horizontally means I'm pulling it out.
So would that
What
be
would the number be?
It would mean that it's greater than 2 still. Yeah. Is that what you asked me? Mm-hmm. All right. So our prediction is that here is going to end up compressing. So let's go to the graph and see what happens. So I'm going to hit tab and I'm going to type in 0.5x squared. And what did it do?
It compressed.
It compressed. It got a little stubbier. Okay? Think about if you take someone who's really, how can I say this and not sound rude? I don't know. What if you had someone who was really tall and all of a sudden you try to stretch them down to a little small? They're going to become like a little Oompa Loompa because you just took them from being real tall and skinny to being, oops, that's all you got. But, or let's think about it reverse-wise. Compressing to stretching. All right, you know how you have those little chubby kids? You're like, oh, man, they're so chubby, and they're just chubbling around, right? All right, but as they get older, they're going to do what?
Stretch.
They're going to stretch. So all that chubbiness is going to do what?
Is chubbling a word?
I don't know. I don't think it really is, but
Chubbling around.
it's okay
Is that
to...
how you want your kid? You want them like troubling around? I thought you said troubling at first. In Mr. Jones' said troubling. I thought you said troubling.
All right. So this is going to end up compressing. So if it's greater than 1, it's going to stretch. So therefore, when it's less than 1, it's going to do what? Compress.
Oh my God.
All right. Now, the thing is that the function is, when I say less than 1, we're going to be less than 1 but greater than 0. Because we don't care about it being negative because we know when it's negative, that's telling us it's doing what?
That's reflecting.
It's reflecting. Yes. We will have restroom passes tomorrow. Quickly.
So is the red one the half X thing?
No, the red one is my 2x. So, this was my... And then the black one is my half it. I need a new battery. I'm sorry. It's taking 24 hours to just get there.
It's on the same.
No, it was on 50 yesterday. It's on 55 today.
It was on 55.
No, it was 55 yesterday.
Oh.
Why we just why we being
It needs a
distracted
battery.
by clock?
Thank you, Noe. All right, so now we are looking at our next part. What if I have my parent function, but I want to add some additional numbers to it or subtract something from it? What is that going to happen to my parent function?
You do the opposite.
Why does it plus 1?
I'm on the outside of my function.
It's gonna
Horizontally,
move
right?
vertically.
It's going to move it vertically because my y values are being changed, right? Because if y equals x squared, that means I'm taking the y value, I'm going to add an additional amount. Because my y values are changing, that means I'm going to be moving up and down. So if I'm adding 4, what does that tell me I'm going to do?
Why is it adding 1?
It was a typo. I don't know what happened. Typo. Okay, so if I'm adding 4, it's going to cause my graph to, what's our prediction?
Shift vertically.
We're going to shift, there you go. Can I just write up?
4 units.
Because hopefully you know that up means to go vertical.
But what is down?
Down is also vertical.
Oh.
Left and right is horizontal. All right, and our prediction for the -5 is?
Shift down.
It's going to cause us to shift down. All right, so let's go and make our prediction. Let's see if it's right. So I'm going to go to the calculator, and I'm going to hit tab, and I'm going to take these out. So I'm going to first add 4, see what happens, and I'm going to subtract 4. Subtract 5, right?
Yeah.
All right, were we right?
Hold on, wait. X squared.
Yes.
Did our shape change? No. The only thing that changed is our physical location. It may look like the shape changed because of what our window setting is, but our shape is still maintaining the same. It makes kind of a rainbow.
No,
No?
not enough.
I see it.
Well, that's a funny rainbow.
It's a spacious rainbow. All right, so then I'm going to move down 5. And that one I'll make. And then I'm going to move up 4. I'll let it be green.
So when there's a number inside with the x that's multiplying or dividing, it's going to be pressed and straight this way.
Okay? If I had... The reason why we don't talk about the number inside with x with squares is that sometimes it's hard to see the difference. But when we do other parent functions, it's easier to see the difference between the two. Now, when I say number inside, if this said 2x plus 3.
So then we're going to do the opposite, right?
Yeah, but what Nick is asking me, this is where it would be a horizontal stretch and horizontal compression. Because the number's inside and it's being multiplied by x.
So if it's being multiplied by x, that means it's
That's horizontally.
Oh, change it.
If I'm multiplying to x, I'm changing horizontally. If I'm multiplying on the outside, that's affecting y, so I'm changing vertically. All right, now we're just going to focus on my constant. If I'm adding a constant or subtracting a constant on the inside, what is that going to cause my function to do?
Shift horizontally.
I'm going to shift horizontally, right? All right, so if I'm a plus 3, it's going to cause me to shift what?
Left.
Left. If I'm a minus 4, it's going to cause me to do what?
Shift 4.
Shift right.
Shift right.
Shift forward.
All right. Oh, it's not allowing me. Okay. I guess I have to draw it. So I'm going to... And then 3 to the left?
Yes. Trying to put it under the line. But it's okay, we know it's
You know what I'm going. And then we're going to go 4 to the right. And those are my shifts.
Those are better.
I think I did pretty decent. All right, do we all remember this?
Vaguely.
Yeah.
But it's not as hard as you thought it was last semester. All right, we're going to do number 5 together, and then you're going to do 6, 7, and 8 in your group. Once you're done with this, then you have the remainder of class to work on your homework. When you get to the homework, it's over transformations, and we're reviewing factoring.
Oh, shucks.
Yes.
So this does go inside.
Huh?
This goes inside.
Yes.
Homework package on here?
You don't have to put it in a pocket. You can glue it in however you want to do it. But yeah, it goes in your notes. All right. So 5. How many transformations happened on 5?
3.
3. All right. So Nick says 3. Anyone disagrees? So I should have 1, 2, and 3 effects. What's my first effect? Reading from left to right.
It's what's it called? Down, click over the x-axis.
All right. So I'm going to be reflected over x-axis. Okay. What about 2?
Left 2.
I'm going to be moved left 2. And what about the third transformation?
Right one.
It's a negative 1.
Down 1.
Okay, that's what you and your partners are going to do. Partners is going to do for 6, 7, and 8, and also on your homework for 1 through 4.
That's all we got, alright?
Hmm. Mhm. Good.
So basically, just by looking at it, you can determine.
You should be able to determine what's going to happen to that graph. Okay. All right.
So if it's negative, it's
Oh, it's going to be reflected over the wall.
oh,
Is that the wall?
yeah. No, it
What's not with it?
doesn't matter.
But what is it?
It's still gonna stretch.